So, good morning, everybody. Good morning, everybody.
Good morning.
This is Beatriz Plaza speaking from the Faculty of Economics and Business from the University of the Basque Country. We are in the lectures, in seminars for lectures in data science this week within the project Education for Technological Literacy and Inclusion. This is a key action tool project of Erasmus Plus run by the European Commission. These projects, the main purpose of these projects is to improve innovation in teaching, and in this case, we are improving teaching at a high education level in connection with disruptive technologies, emerging technologies. You can see the website there, okay? Yesterday, we did an introduction to data mining, to data science. The methodology is very, very practical. The most important thing is the understanding. The case studies come from culture management and culture tourism, and also urban economics and analysis of cultural infrastructures in urban setting. And the reason for this is because of the history of the consortia. Within the consortia, we have been working together for more than 10 years. We have run European projects together. We have run summer schools together. We have run international conferences together, always in the field of culture management and cultural investments in urban settings. And this is why we are applying these quantitative methods and data mining to very practical case studies in culture management. Okay. Yesterday, we started by metrics, general metrics, digital metrics. We started by defining the concept of information goods by Shapiro-Barian, the famous book published by Shapiro-Barian in 1999 on information goods. Information goods are any good that can be digitalized. They are digital. Once they are digital, the marginal cost of reproduction is close to zero. So reproduction, if there's no barrier or protection, reproduction is very easy because it's very cheap. Once it is produced, it's very cheap. And from the demand side, we saw that the more we consume culture goods, if they are really real pieces of art, very singular in their kind, the more we consume them, the more we like them. So we are operating under increasing returns to utility from the demand side. The combination of the increasing returns to utility from the demand side with the cost pattern of digital images and information goods in general generates the network economics under which we are operating. As I already mentioned, in the book by Shapiro-Barian, you can also find the business models there in connection with information goods. Then we analyze some digital metrics in culture tourist destinations in connection with geolocalization, extraction of data, which is geolocalized, semantic data also in culture tourist destinations. And then we moved on to Google Trends. Kari, I have been checking the art management and culture management keywords, and I will come back to you once I have deepened into this topic, okay? So we learned how to destationalize monthly data. We downloaded the data from Google Trends and destationalized it. And also we downloaded weekly data from Google Trends and learned how to destationalize it, okay? In fact, we used the case of Cremona violin. Yes, Cremona is famous city in Italy, famous for making handmade violins and string instruments. Okay, it is easier to operate Google Trends when you are looking for strong brands. Weaker brands don't operate so nicely. So when we analyze stronger cultural brands, it's much easier to analyze the data in Google Trends. And then last but not least, we moved on to Google Analytics. We went into a website, a specific website. We saw where the data comes from. We will perform some data mining tomorrow when we go to regression with cross-sectional data. And then we moved on to the analysis of patterns, within Google Analytics. In fact, data science is always, in data science, we are always analyzing data patterns, okay? We are always data mining, that is extracting data, cleaning data, testing the quality of data, of the extracted data, and then we can analyze the topology of the data, or we can also test the causality, the correlation or causality. Okay. So, having said this, do you have any question in connection with yesterday's presentation, if I may? It's never late, so then, okay. I think, yes, please.
The digital metrics, the statistical transformation, we saw it when? Because I was already a little bit tired and I didn't understand this part very well.
Yes, we did the destationalizing, okay, and then we will move on tomorrow with more transformations.
But on Google Analytics, we didn't make this statistical transformation, no?
Not yet.
Okay.
Yes.
Okay, thank you.
You're welcome. Any more questions?
I had one question.
Yes, please.
So we looked at Google Trends and Google
Okay.
Analytics. Do we have any idea of how, of all the internet users, how many use Google and how many use other of like Firefox and other browsers? Like, do we have any figure?
Yes, that is a good question. Within the European Union, 95% of the users use Google, okay, as a search engine. And then the browsers market is divided. Before, Firefox had a high portion, but the browser by Google is advancing, okay? So that situation is changing. I have some students we have some students from China, and obviously they are operating with different search engines, and these search engines by Baidu are operating also their own analytics, okay?
Okay.
So there are some alternatives there in the market.
Thank you.
Any more questions? You're welcome. Okay, so now we can start with the second day. The second day. It is Tuesday, June the 20th, and we will focus on network analysis. Okay. maybe we can last later or maybe earlier. There are 3 very short sessions, and once we'll see. But we will stick to the schedule. Okay, so we will have an introduction, some centrality measures, and some calculations. Everything is available, will be available online. And also we can have another session after summertime in autumn between September and December to clarify some concepts in connection with this seminar. As there will be a second seminar on coding for data science. And there, obviously, we will start that seminar by a recap of all the basics delivered here. Okay. Excuse me. Can I kindly ask you to close your microphones, please? Switch off your microphones, please. Okay, can you see the PowerPoint? Mobility patterns and network analysis?
Yes.
Yes.
Thank you.
Okay, let's start then. We will have 2 parts here, okay? And we will try to ask ourselves whether it makes sense, why it makes sense to use this type of methodologies and whether it makes sense, okay? First, we will start by the territorial perspective. We are talking about mobility in cultural destinations, cultural tourist destination. We will analyze these mobility patterns, and then we will calculate the network analysis of this GPS data. So the first question would be, in cultural destination, does accessibility matter? This question is key because yesterday we saw the case of the Galapagos. Do you remember? Galapagos, they are wonderful islands, really iconic, very intensive in beauty. And if I consume a lot of images of the Galapagos Islands, my willingness to travel changes. So the notion of distance changes, okay? The consumption of digital goods or cultural goods has the capacity of changing the notion of land, the notions, of distance, the notion of distance. So having said this, this means that maybe I am willing to visit a place which is far away with very high transaction costs, although it is time consuming and although it is expensive, okay? So the consumption of digital art and culture goods has this capacity of changing the concept of distance. So the question will arise is, knowing this, that the subjective perception of distance can change in this field, does real accessibility matter? This is what we are going to analyze. Real accessibility means the transportation connectivity. So now, at this first session, we are talking about material physical transportation networks, okay, of cultural tourism destinations. So we will define which are the network, very basic network metrics: degree centrality, closeness centrality, betweenness centrality, eigenvector, and geodesic path. And but we will try to get to learn these concepts through very practical case studies. Voila, so here we are. This is a network that encompasses the top 25 airports worldwide, okay? I'll give you 5 minutes to have a look to this network. Can I kindly request you have a look to this network, and within 5 minutes I will start analyzing the network, if I may. Or maybe 3 minutes. Can you see the network properly?
Yes, thank you.
Okay, so I think I'll start analyzing the network. Well, this network encompasses the top 25 airports worldwide. So this means that even the smallest node means an airport in this case, okay? The smallest node, even the smallest is important because we are talking about the top 25, okay? Having said this, not all the size of the nodes is not the same. In this graph, the size of the node measures betweenness centrality, and I'll explain this later on, okay? But the two nodes with highest betweenness centrality are London and New York.
Yeah.
So this, in popular language and everyday language, they call them hubs, okay? Hub is a node with high betweenness centrality. Hub is a node with high betweenness centrality. Okay. Okay. So it is not the same for a smaller city to be connected to a hub or not to be connected to a hub. It's not the same. Okay. For any smaller city, it is key to have a direct connection with a node with high betweenness centrality. Okay. You can see that here you have these two nodes with high betweenness centrality. Then the two nodes are connected among them, New York. You can see how wide is the link between New York and London. This means that they are really, really well connected. And the remaining nodes, most of them are directly connected with one node or another, okay? And this is the typical topology of networks of transportation. So if we were to analyze the distribution of betweenness centrality, we have some few nodes with high betweenness centrality, and then the remaining nodes have low betweenness centrality. And the important thing is the connectivity to the node with high betweenness centrality. Okay. Okay, I'm going to explain maybe, I don't know whether it's clear or not, but I'm sure that we will understand this concept after analyzing 2 case studies. These are real case studies, okay? One is the case of the Canary Islands. Canary Islands, these Canary Islands had 18 daily direct flights with Iberia. Iberia is a regular company running between Madrid and the Canary Islands, okay? But at one point, from many European cities, they started operating low-cost flights to the Canary Islands, okay? And as a result of this, these low-cost flights operating from many European cities, as a result of this, Iberia decided to diminish the amount of regular flights connecting Madrid with the Canary Islands. And surprisingly, there was a decline in tourism. I say that surprisingly because there were so many low-cost flights operating directly from different cities, most of them European cities, operating directly with Canary Islands. The question here is, what happened that the substitution of regular flights, regular connections between the Canary Islands and Madrid, this diminishing of regular flights had a negative impact on tourism in the Canary Islands? And the answer is the following. Madrid has high betweenness centrality. This means that it is a connector. Traditionally, it used to receive connections from other European cities, and within 2 steps, they used to get to the Canary Islands. Okay, so these nodes with high betweenness centrality are gateways. Once you kill or once you delete these regular flights with the node with high betweenness centrality, in this case, if you diminish the number of flights between the Canary Islands and Madrid, which is a node with high betweenness centrality, you are diminishing the closeness centrality of the Canary Islands. I know that there are many concepts within 2 minutes, but within half an hour or within an hour, as we will be studying this once and again, we will get used to this language of the metrics of network analysis. Okay. Okay. For instance, I'll give an example for Bilbao. Bilbao is a second-tier city. Okay. Bilbao is a second-tier city. It is located in the northern part of the Iberian Peninsula of Spain, very close to the French border. Okay. Closeness means that how close you are in terms of steps. Okay. Steps means one step is the link between 2 nodes. Okay. This is 1 step. So if I imagine that I'm traveling to Osaka. This is real, okay? If I manage to travel from Bilbao to Osaka within 2 steps, will it be good news or bad news for Bilbao?
Good.
It will be excellent news because probably I would fly Bilbao, Frankfurt, Osaka, okay?
Yep.
So for any second-tier city, Bilbao is a second-tier city by the European standard, and it's a third-tier city by the global standard. So for any second-tier city, it is excellent news to get, if you manage to reach any city, anywhere within 2 steps, okay? When do you manage to reach everywhere within 2 steps? when you are very well connected, when your airport is very well connected with nodes with high betweenness centrality. And this is key. Your connection with high betweenness centrality. And this is key. Okay. Because the better connected a second tier city is with hubs, that is, with nodes with high betweenness centrality, the closeness centrality of Bilbao would be higher. Okay, the closeness centrality of Bilbao would be higher. Okay. So for Bilbao, it is key to be directly connected to nodes with high betweenness centrality. So as I get, for instance, Bolivia, Bogota. Within how many steps I can get to Bogota from Bilbao? I can get to Bogota. Bogota is in the American continent, South America. I can get to Bogota within 2 steps. Bilbao, Madrid, Madrid, Bogota. So how is the closeness centrality of Bilbao? To the extent Bilbao reaches any important city, globally speaking, within 2 steps, the closeness of Bilbao would be high, okay? Closeness of Bilbao will be high. But the key thing is that it is well connected with these nodes with high betweenness centrality, because the direct connection with these nodes with high betweenness centrality will give Bilbao high closeness centrality. Okay? Okay. Having said this, I'm going to stop this presentation and I'm going to go to the theoretical presentation on network analysis. Wait a minute. It is a little bit theoretical. I'll try to be practical. Here we are.
Not seeing.
Yes, wait a minute.
Okay.
Can you see it now?
Yes, thank you.
Okay, so this will be a very brief and theoretical analysis, because in order to advance in the more practical approach, we need to have the basics of the theory of network analysis. Okay? Okay. So we are going to analyze degree centrality, closeness centrality, betweenness centrality, and eigenvector. And also a concept which is not here, which is geodesic path. This degree centrality, eigenvector centrality, betweenness centrality, and closeness centrality are metrics connected with each node. In the case of airports, each airport was one node, okay? And the connection between the nodes we call them links. So we have nodes and we have links, okay? Degree centrality. Degree centrality of a node is simply the number of edges connected to the node. That is, degree centrality is simply the number of links connected to that node. For instance, which is the degree centrality of A here? A has 2 connections. On the left-hand side, you can see A, the node A, okay? A has two direct connections, okay? A has 2 links, so degree centrality of A is 2, okay? Degree means the number of direct connections, okay? Eigenvector centrality. The basic idea behind eigenvector centrality is that the importance of a node depends not only on the number of its connections, its direct connections, but also on the importance of those connections, okay? So imagine that this means that in eigenvector, we see A here. A has two direct connections, so degree is equal to 2. But in eigenvector, we would also take into account whether B and E are important nodes. Okay, so there is a ponderation. In eigenvector, there is a ponderation. We will use eigenvector in the third session today. And the second one in connection with repositioning cultural infrastructures globally. Okay, so in eigenvector, we also take into account, we don't only take into account to whom you are connected, but also whether these nodes are important or not. Okay. Between centrality. Between centrality is a measure of node importance based on the extent to which a node lies in the shortest path between other nodes. Differently said, I'm going to explain it through by using the concept geodesic path. Geodesic path is the shortest path between two nodes. Okay, this is the definition of geodesic path. In economic terms, geodesic path means efficiency, because we are talking about the shortest path. So let's analyze the two paths between A and D. Okay, we have two paths between A and D. A, B, C, D is one path. Okay, and A, E, D is a second path. Which of the two is the shortest? A, B, C, D or A, E, D? The shortest one is the second one, A, E, D, because A, B, C, D, we have 1, 2, 3 links, okay? So 3 steps. The path that goes from A to B, that one path has 3 steps, whereas the lower one, A, E, D, has 2 steps. So the geodesic path is the lower one, okay? The geodesic path is the lower one, okay? I'm showing this because I'm trying to explain things easily, in an easy way, but sometimes it is helpful to see the formula, okay? Do you see the pointer?
Yeah.
Yes. So between the centrality between J and K of the node N means of all the geodesic paths within the network, how many geodesic paths go through N? This is the concept of betweenness centrality. Okay? Okay. Conrad, for instance, here. Would you say that Conrad has high betweenness or low betweenness? It has high betweenness.
High.
Very high, okay? Because there are many geodesic paths that go through Conrad, okay? Here, for instance, let's analyze betweenness centrality here. We want to analyze betweenness centrality of the node C.
C.
How C? We are analyzing the node C, okay? How many geodesic paths go to through C, sorry. Would we say that 100% of the paths go through C? Yes, because AB goes through C.
Yeah.
AD goes through C. AE goes through C.
Yeah.
BD goes through C. BE goes through C. DE goes through C. So all the geodesic paths that are in this network, 100% of the geodesic paths go through C. So the betweenness centrality of C is 100%. Or if we analyze it in a normalized, it could be 1. If we analyze between 0 and 1, the betweenness centrality of C would be 1, being the maximum. That is 100%. 100% of the geodesic paths go through C. So would we say that C is a very powerful node? Yes.
Yeah.
The node C has the whole information. The node C has the whole information, because if this were a network of information, okay, C has access to all the information, okay, because every single piece of information goes through C. So C has huge betweenness centrality, and this means that C has huge power, okay? Huge power. The relation of power between the other nodes in C is very uneven, very uneven. It is very uneven because C has the maximum of betweenness centrality, the maximum of betweenness centrality. Okay? Okay. So I'll come back to this afterwards, but I want to go to the transportation cost, transportation network again.
Mm-hmm.
Okay. This one. So which is the power of New York and London in terms of transportation networks? Very high.
High.
Because they have huge betweenness centrality, okay?
Mm-hmm.
So any city which is connected to London or New York has a direct connection in regular flights. That city has high closeness, okay? Closeness means the number of steps you need to reach everywhere, okay? This is the concept of closeness. So for any second-tier city, for instance, the case of Bilbao, okay? This is in Spanish, but I'm going to translate it now into English. It says, British Airways will stop flying to Heathrow and will operate flights between Bilbao and Gatwick.
Mm-hmm.
Okay? Well, this was very bad news for Bilbao. Very bad news for Bilbao. Why? Because Heathrow has huge betweenness centrality. What happened here? What happened here was that EasyJet started operating low-cost flights from Gatwick to Bilbao, okay?
Mm-hmm.
And as a result of this, these low-cost flights being operated between Gatwick and Bilbao, the competition increased, and British Airways decided to switch the direct flights between London and Bilbao, to switch it from Heathrow to Gatwick. The only problem is that the betweenness centrality of Heathrow is explosive, whereas the betweenness centrality of Gatwick is not as explosive, okay? The Heathrow and Gatwick have totally different betweenness centrality. So it is not the same. It is not the same to connect the city of Bilbao with Heathrow, because Heathrow is the gateway to everywhere, globally speaking, that to connect the city of Bilbao through British Airways to Gatwick, okay? Because as a connector, as Gatwick has a lower betweenness centrality than Heathrow, as a connector, its connecting power is much lower than Gatwick, okay? Okay, and this is key. This is key. Okay, this is key. It is key to have a direct connection to nodes with high betweenness centrality, especially when you are a second-tier city. Especially when you are a second-tier city. Okay. So closeness for Bilbao would be Bilbao is a second-tier city by the European standard. I repeat again, that is a third-tier city by the global standard. For a city like Bilbao, having connectivity is like a popular way of saying that you have high closeness centrality. Okay, Having high closeness means that you reach everywhere within 2 steps from Bilbao. This is the meaning of having high closeness. Okay. The maximum of closeness would be reaching everywhere within 1 step, and this is the case of London and New York. London and New York reach everywhere within 1 step. They can reach, maybe not everywhere, but almost. They can reach 90% of the important cities globally within 1 step. Okay, so for the case of Bilbao, achieving high closeness would be reaching everywhere within 2 steps. Okay. This is key because there is a change in the concept of distance. What is distance? Is it only kilometers? Not really. Not really. It's not only kilometers. Okay. Distance also is the number of steps that you need to reach from your hometown to the destination. Okay. And that is a concept of distance, which is also necessary to analyze the cultural destinations in this city ecosystem globally. In this city ecosystem globally. So it is not the same to have a cultural tourist destination within 2 steps than to have a cultural tourist destination within 7 steps, if I may. Okay, it's not the same. Yeah, to have a cultural tourist destination within 5 steps, or to have a cultural tourist destination within 2 steps, is not the same. Okay. This means that although cultural destinations are subject to the intensive consumption of information goods, which changes the subjective perception of distance, in reality, the transportation infrastructures also matter. Okay, and the topology of this network matter. And it is important, if you are a cultural tourist destination, it is important that you have high closeness. It is important that you have high closeness. That is, that at least they reach you within 2 steps. Okay, this is key. Although they are traveling from the African continent, it doesn't matter. Okay, it doesn't matter at all. It's a question of a number of steps. Maybe they are traveling from Johannesburg, London, Bilbao, 2 steps. Okay, or Cameroon, Amsterdam, Bilbao, 2 steps. Okay? So this is key. This is key. Also, it is also key because more and more cities are leading the economy. Cities and the hinterland of cities. It is true that we are operating under states, and the legal systems are states, but in real life, cities are becoming more and more powerful, and the hinterland of cities. So the GDP, for instance, there are cities globally that have much bigger GDP than countries. For instance, New York. The GDP of New York is much bigger than many countries, okay? So New York could be an independent country on its own, because it has such a big GDP, New York, for instance, that it could be become an independent country. Okay, so as to say. So this is just an example to analyze how cities matter. Okay, and the global positioning of cities matter. Okay, more and more in all economic activities, but in cultural tourism, it is very clear that it matters as well. So here we analyze the case of Bilbao with Heathrow. Bilbao, when British Airways switched from Heathrow to Gatwick, it wasn't good news for Bilbao, okay? Because it was switching from an airport, Heathrow, with huge explosive between a centrality to Gatwick, which are much lower between a centrality. Luckily, Bilbao is connected to Frankfurt, which has huge explosive between a centrality Munich, München, big betweenness centrality. Amsterdam, big betweenness centrality. Paris, huge betweenness centrality. In Madrid, Madrid is the gateway to Latin America. Okay, every single flight to Latin America goes through Madrid. Okay, so no, we can reach any South American city within 2 steps through Madrid. Okay, and this is key. Okay, so I'll stop here and go back to the indicators, if I may. Okay. Can you see it? So we have degree centrality. Degree centrality is the number of direct connections of a node. Okay. Then we have eigenvector. Eigenvector, we'll analyze it later on, but we don't only have into account the direct connections, but also the potence of the nodes to which you are connected. Okay. Then betweenness centrality, we analyze this case study to analyze the betweenness. Here betweenness of C is 100%. So if we analyze the normalized betweenness centrality of C, the node C, it will be 1. Okay, 0, the maximum between 0 and 1 is 1. Okay, it will be 1. Okay, that is 100% of the geodesic paths that within this network, 100% of the geodesic paths go through C. So C has huge power. Okay, geodesic path is the shortest path. And the definition of shortest path means the number of steps. The number of steps. Here we have 2 paths from A to D. The upward path with 1, 2, 3 steps, and the down one, AED, with 2 steps. So the geodesic path is the second one. Nowadays, in the connectivity economy, the smaller the number of paths, the better. Okay? Here, nowadays, in the network economy, the smaller the number of paths, the number of steps, in the paths, the better. Okay? Because we need accessibility, we need to diminish transaction costs. So it is key to diminish the number of steps of your connectivity. And if you manage to diminish the number of steps of your connectivity, we are saying that you are increasing your closeness, okay? You're increasing your closeness. Closeness centrality is a measure that quantifies how close a node is to other nodes in the network. How close means the number of steps, okay? How close, okay? So it could be far away in kilometers, but very well connected. So maybe imagine that I have to travel to Tallinn. Tallinn, it's the northern part of Europe. For me, it's easy because it's only 2 steps. Okay, Bilbao, Frankfurt, Tallinn, within 2 steps. Or Helsinki, for instance. Bilbao, Frankfurt, Helsinki. This is key to reach within 2 steps every single cultural destination. Okay, and these are the formulas here. This is from the project SERPIN. The left-hand side, you have the degree centrality of the node C, which means direct connections between nodes, okay? And then we have closeness. Closeness is the number of steps to all the destinations. We have betweenness. Betweenness centrality is the number of geodesic paths that go through N over the total number of geodesic paths. But the important thing is to understand the concept, not so much the formula of it. Any question in connection with this? Okay, so I'll go to the presentation again. These are the airports, okay? These are the airports. Excuse me, these are the ports. Bilbao is a port city.
We cannot see them.
Cannot.
Beatriz.
I cannot see it.
Oh, no? Okay.
Anuka is saying she's trying to come in. She's having internet problems.
Okay. Can you see it now?
Yep.
These are the port connectivity.
Okay.
Bilbao is a port city. Bilbao has a port, okay? But it is a second-tier city. As we mentioned, by European standard, and that means a third-tier city by the global standard, okay? Is it important for Bilbao to have direct connections with nodes with high betweenness centrality? And the answer is yes.
Yeah.
It is key for Bilbao as a port to have direct connections with nodes with high betweenness centrality. If you, a direct connection is degree centrality. So if you see the graph on the right-hand side, you see that Bilbao has a direct connection with Rotterdam. Can you see it?
Mm-hmm.
So this is good news. This is good news because the port of Bilbao has a direct connection with a node with high betweenness centrality, which is Rotterdam. And this is key. This is key. To have, for any second-tier city, it is key to have a direct connections in the transportation infrastructures to nodes with high betweenness centrality. To nodes with high betweenness centrality. So it will be much easier for the Port of Bilbao to operate globally if the port is connected directly with a node with high betweenness centrality. If a container is traveling from Bilbao to New York, it will go Bilbao, Rotterdam, Rotterdam, New York, okay?
Mm-hmm.
Probably Bilbao, Rotterdam in a smaller ship, a smaller container ship, and it will be reloaded to a huge one that is traveling from Rotterdam to New York, okay? Okay. Here we can analyze the maritime law offices. As you see, we are always analyzing cities, okay? And why? Because more and more cities and their hinterland concentrate a bigger percentage of the GDP globally. So connectivity between cities matter, okay? Connectivity between cities matter. Here, these are maritime law offices, and this is the network. Which is the node with the highest betweenness centrality? With almost a monopoly, London. London, and it makes sense. London is a financial hub, okay? London has high concentration, although with Brexit, this concentration has diminished a little bit. So this means that the betweenness centrality of London has diminished a little bit, okay? But they are experts in highly sophisticated financial products in London. So the normal thing would be operating financial insurance products from London, okay? So from the business point of view, if you are an expert in business and you are analyzing the maritime law offices and you see that London has a huge betweenness centrality within these maritime law offices, it makes sense because they are operating all these insurance companies in connection with maritime transportations, okay? Okay. These are the top 100 multinational companies. I think this is a little bit old-fashioned because probably the Asian cities, especially Chinese ones, have a much more better positioning nowadays, and they are leaders in many sectors. But for this class, I think this is enough, okay? So we are analyzing the global top 100 multinational companies. And here we are analyzing the value chain. The value chain means that where do these companies produce? Okay, this is a segmented value chain. So they are, you can see which are the nodes with high betweenness centrality. So I'm not going to analyze it. In the European map, you see that you can see the northern part of France, Belgium, southern part of Germany, northern part of Italy is have high centrality, and it is interesting to see the position of Madrid. Okay, the position of Madrid. Madrid has a direct connection with nodes with high betweenness centrality, and the question here is why Madrid, which is in a Iberian Peninsula, so somehow from a territorial perspective, it is a territory which is not very central within the European Union. However, when you analyze the multinationals, Madrid is very well positioned globally, among the 100 multinationals globally. And why is this? It is like this because Madrid is the gateway of Latin America, okay? And there are many companies that operate with South America and Latin America from Madrid. So the amount of joint ventures operating in Madrid is huge, okay? So Madrid has a comparative advantage in connection with the Latin American market in global terms. Also, you have the issue of language. Language, Portuguese and Spanish are very close languages, so it is easy to operate in markets with the same language. Okay, so maybe we can have a 10 minutes break, if I may. 10 minutes break, and I'll come back within 10 minutes.
Okay.
Is this okay?
Okay, thank you.
Yes.
Perfect. Thank you, Beatriz.
Thank you,
See
Beatriz. Thank you.
See you within 10 minutes.
Okay, bye.
Bye.